Hi guys, this is Nitin from FTC Team 18172, Uplift Robotics, and in this video, I'll be going in-depth on top-down design in FTC using skeletons in Creo. Within the design process in CAD, there are three main methodologies in how to approach building a robot. In FTC, your robots may have an assembly that contains the full robot, and then several sub-assemblies for the drivetrain, intake, and any mechanisms, and then several sub-assemblies before reaching the individual components such as wheels, axles, and custom parts. One approach in CAD is bottom-up design, which starts with taking parts and combining them into larger assemblies similar to how you'd assemble things in real life. For our robots, you may start with a wheel and axle mounted to a chassis frame and then add motors and other mechanisms until you have a full robot. This is great for many applications, but if you want to change a part, then you have to make changes in multiple assemblies and other parts, which is inconvenient and time-consuming. Instead, top-down design starts with creating the full robot or mechanism assembly in your design first, and working your way down through your model to the sub-assemblies and then the individual components. By using this approach, changes made to one of the assemblies will automatically be trickled down to the parts. In order to propagate the changes from assemblies to the individual components, we use skeletons, which essentially hold all the information for that assembly and send some features of it to each of the components. Skeletons are also designed in ways that accommodate for changes that you can predict for your mechanism, making implementation of these changes much faster. They also create a central location for any changes that need to be made and prevent circular references. Circular references are two or more parts that take features from each other that the other relies upon, which makes the features create a circle where they can't be changed. There is also a third approach in middle-out design, which combines the top-down and bottom-up design processes into one. Alright, now that we've gone over the concepts I'll be using in this video, let's jump into Creo and take a closer look. For the next couple of videos, I'll be creating a drivetrain in small steps using different aspects of Creo to create the components of my drivetrain. So I'm going to go ahead and create a new assembly that's going to act as the top level assembly for my drivetrain. So I'm going to call it drivetrain example. Click on a different template so I can get my metric units. So now that I'm in my top level assembly, I'm going to create a skeleton component. So by doing this, I can go to the component and create a component using the command. And then for the type, I'm going to choose the skeleton models type. You'll notice here there is a subtype for different types of skeletons. For this example, I'm going to stick with the standard skeleton type. In a future video, I'll go over the motion and body skeleton types. But for now, I'll click OK and use my metric units. That's OK. And now my parts has been created. So I'll open it up. And you'll see here that my skeleton has all of the standard commands for a part. And this is because the skeleton is treated exactly like a part in Creo. So I'm going to go ahead and create some sketches for my skeleton, and these will be included in a separate video on sketching that will be out after this video. I'll be using the sketches that I made in that video later for my skeleton and drivetrain, and I'll come back once they are finished. Alright, now I finished all my sketches for my skeleton. If you notice within my skeleton, I split my components into different sketches and datum features, and this will allow me to easily edit and find the parts that I want later on. Within skeletons, you can also use relations, parameters, and MathCAD calculations in order to make your models more iterative and account for potential changes. If you want to implement these types of calculations into your model, then I highly suggest that you watch our videos on relations and parameters and on FTC MathCAD. I've also added datum coordinate systems for each of the drive plates that I'm going to be creating from the skeleton. By adding coordinate systems to the skeletons, I can create local coordinate systems to the center of each of the plates rather than the center of the drivetrain or the skeleton. And you'll see why once I make the parts. So once you've finished building all of the geometry that you want within the skeleton, you can create a publish geometry feature. Publish geometry essentially organizes the features that you make from the skeleton that will be sent to each of the parts. For each part, you should have a publish geometry feature, which sends the information from the skeleton to the individual parts. Alright, so in order to create a publish geometry feature, go to the model intent dropdown and click on publish geometry. Within the command, you can choose three different types of surfaces, chains, or references. So I only have chains and references, so I'll use the chains for the first inner drive plate. So I'll select the sketches that I have for those, so I'll go one by one and use the control key in order to make sure that I have all my sketches populated into my window. Now that I have all my sketches, I'm going to use my references and select on the references that I want. So I'm going to select on them from the model tree this time, so I can get the coordinate system and the 2 drive plates as well. So that looks good. So now I can go over to the Properties tab, and I can rename the published geometry, and I recommend that you do this for each of your published geometries, otherwise it gets very confusing once you have so many of them. So for this one, I'm going to call it Outer Drive Plate PG. And that's good, so click OK. I've gone ahead and created the inner drive plate published geometry and also reorganized my model tree in order for more efficient regeneration. So now that I'm done with my skeleton, I can go back to the top level drivetrain assembly right here. And within the top level drivetrain assembly, I'm going to use the create component command again. And this time I'm going to create a part for the outer drive plate. So that looks good. Click OK. And that looks good as well, so I'll click OK. And I'll leave it at the default constraint for now, and I'll change it later. So within the part, I'll open it up, expand the window, and now within this part, I need to get the features from my skeleton. So in order to do this, I'm going to create a copy geometry feature from the Get Data tab. I'll click on it. And within the copy geometry feature, it's going to take the published geometry from my skeleton and send the features from that published geometry to my drive plate. So for the copy geometry, there's 2 ways to access the skeleton file. One is through the assembly, and one is through the external reference. I would recommend using the external reference so the 2 parts are directly linked to each other rather than going through the assembly and then back to the skeleton. So I'll click on the external reference and use the open command to get the skeleton part that I want. So I want that. So now I have opened the placement dialog box, and here's where the coordinate systems come into play. So I can use the placement method to be the coordinate system, so I can set the coordinate system that I created within the skeleton to be the same as the default coordinate system within my drive plate. So I can click on the coordinate system that I created from my skeleton and the local coordinate system, which is the default coordinate system, and click OK. And now this creates the local coordinate system within the center of the part. So now I'm going to select the published geometry from my model tree, and I'll click on the outer drive plate published geometry. That looks good. So now it's all my references are satisfied. So I can click OK. And now you'll notice that I've gotten my published geometry into my drive plate. In order to create the actual drive plate from these sketches, you can always use the project tool and you create a new sketch on the plane and then extrude, but instead I'll show you a slightly faster way. If you go down to the item filter, you can select the sketch region filter. So now when I click on the sketch, you notice that it automatically selects the entire region that I want to extrude. So I can select that, use the extrude button, and now it automatically it creates the extrude feature for me. So I can select the depth to be up to a datum plane and use the datum extrude plane that I created from my copy geometry. So I can select that, and now it creates the plate. I can click OK, and it's automatically created the drive plate for me. And all it did was take a few seconds using the skeleton features. I'll do the other drive plate off camera, but with these parts, you can now assemble them into the assembly, but I'll do that in a future video. As always, the Creo files made in this video will be in our GitHub repository in the description. If you have any questions about skeletons, top-down design, Creo, or FTC in general, feel free to contact our team through our social media information in the description. As always, thanks for watching, stay tuned for more tutorials in CAD, FTC, and more coming soon.